We are Team Vision X, and our project is Aqua Sentinel, an AI-driven floating robotic system that combines water pollution monitoring with rescue functionality. It is a fusion of our existing rescue robot design and an AI-powered hyperspectral monitoring system, making it a dual-purpose platform for environmental and emergency response. The system operates in two different modes, monitoring mode and rescue mode. In monitoring mode, the robot moves on the water surface using its thrusters. The AS7265x multispectral sensor continuously measures the water quality and detects color-based changes caused by algae or pollutants. The ESP32 processes this data and identifies whether this water is clean, polluted, or eutrophic. If eutrophication is detected, a servo-control spraying mechanism activates to release the needed treatment chemical. In rescue mode, in emergency condition, the robot detects human presence using sensors or camera inputs and communicates the live GPS coordinates to the control center through LoRa for quick response. At the core of our design is the ESP32 microcontroller, which acts as the main brain of the robot. It collects data from different sensors, processes it, and controls both communication and mechanical operations. The most important sensing unit here is the AS7265x multispectral sensor from SparkFun. It measures the reflected light from the water surface across 18 different wavelengths, ranging from visible to near infrared light. Using this data, we can easily detect chlorophyll presence and plastic pollutants. This helps in identifying eutrophication level in water body. Once the ESP32 receives this spectral data, it adds a timestamp using the DS3231 real-time clock module and stores the full dataset in the SD card module. This ensures every reading is properly recorded for later analysis, even if the robot temporarily loses communication. The same ESP32 also sends the summarized data packet through the LoRa transceiver module. The LoRa, which stands for long range communication, helps the robot send sensor readings, GPS location, and status updates up to 5 to 6 kilometers away, even in areas without internet or mobile network. On the mechanical side, the ESP32 controls a servo motor and pump mechanism that can automatically spray the required medicine into the water when eutrophication or pollution is detected. This makes the robot not just a monitoring system but also an active treatment platform. For navigation and location tracking, a GPS module continuously provides coordinates that are sent along with the sensor data. In rescue mode, this helps guide rescue team directly to the affected spot. To make sure that the system stays stable and balanced on water, we use a stable floating body with two thrusters for smooth motion and easy control. The waterproof electronics compartment houses all the modules safely, while the spraying nozzle and sensors are mounted on the top for direct water analysis. In short, all these components, the A7265X sensor, ESP32 controller, LoRa communication, SD, RTC, GPS, and servo-pump mechanism are connected together to create one smart and self-sufficient system. The ESP32 acts as the link between all these parts, handling data connection, control, and communication in real time. The tight integration between mechanical design and embedded hardware allows the Aqua Sentinel to monitor, analyze, and even react to water pollution completely on its own, while keeping the base station updated through LoRa communication. Now going on with the work done through AI part.
Once the hyperspectral sensors collect reflection data from the water surface, the AI module of Aqua Sentinel begins processing. The raw data is first processed to remove noise caused by sunlight and wave movement using adaptive filtering. The clean data is then analyzed using machine learning model that extract spectral signatures to determine two key factors: chlorophyll concentration and plastic type. The chlorophyll analysis maps the varying spectral intensities to estimate concentration levels, while the plastic detection module classifies materials such as PET, HDPE, and LDPE based on their spectral response. Each analyzed data point is geotagged and sent in real time to our React-based web GUI, where users can monitor everything live. The dashboard displays a bar graph showing chlorophyll levels across zones and markers identifying plastics, each color-coded by type. This gives a clear, interactive view of water's condition at any moment. All processed data is securely stored both locally and on cloud. and we plan to make it available as open source data for research and public environment analysis, supporting transparency and collaboration. In summary, Aqua Sentinel integrates robotics, AI, and hyperspectral imaging to deliver an intelligent, low-cost, and eco-friendly solution for real-time water quality monitoring. It doesn't just detect and visualize pollution, it enables early intervention, long-term ecosystem tracking, and open scientific collaboration. We believe this innovation can transform how we monitor and protect aquatic environment, making our water cleaner, smarter, and more sustainable for our future.